Hello everybody and welcome to the first Angular meetup here in Leoben. My name is Jürgen Blematl. I'm director of AURENA Tech and I'm really glad that we can host this Angular meetup here today in our experience lab in Leoben. Usually we do user experience testing here, but today we turned our lab into a stage for great speakers and cutting edge Angular topics. We try hard and we want to give everybody the best experience here on location and also for you guys online. Therefore, I do have a request. Please guys here on location, put your question to the end of the talks. I will go around with the mic then so that everybody actually can hear you. For you online, please log into YouTube, write your questions into the chat and we will pass the questions to our speakers. We are going to have two great talks today. The first one will be Angular, the future of Angular with IV by Manfred Steyer. And the second one will be confident Angular testing with Christian Janker. We also do have a third item on our agenda today, and this will be a very interesting interview with Manfred Steyer about his work as a trainer and a consultant with Angular architects. Now let me introduce you our first speaker. He is Google developer expert for Angular. He's maybe one of the first really serious Angular developer from Austria. He is, the founding father of this meetup and the organizer. And he is also a consultant and a trainer for Angular. Let's give Manfred Steyer a very warm applause.
Thank you for having me and for hosting us today here in Leoben. As Jürgen told you, this talk will be about Angular's future with Ivy. And as mentioned, I'm Manfred. I'm a trainer and consultant for Angular. I'm doing a lot of trainings. For instance, this year it's about Angular in the enterprise, an advanced training that shows you a lot of things you need when creating enterprise scale applications. I'm part of the Google Developer Expert team. I'm part of the Angular team as a trusted collaborator. And I live in Austria, do a lot of stuff in Germany. And sometimes I'm in other countries like Switzerland and other countries of the Union. So what is the contents of this talk? I have prepared two topics. The first topic will show you what Ivy can do for you today. And the second topic will show you what Ivy will enable you to do tomorrow. Let's start with the first one, with the current features that come with Ivy. As you might know, Angular is not interested in your HTML. And that's why Angular is compiling your HTML templates into JavaScript. The reason is simple. The reason is JavaScript can be better optimized. It is quite difficult to optimize string replacements within HTML files, but within JavaScript files you can optimize quite nicely. The virtual machine in your browser is taking care about this. And this was true in the past and this is true after Ivy. The only difference is that Ivy is doing this compilation in a much smarter way. When using Ivy, we have up to 30% less bundle sizes, which means your bundle sizes will shrink. It depends upon your style of your application. Very tiny application will benefit a lot, but also a lot of huge applications will benefit a lot. If you have a mid-sized application, it won't benefit that much. Here you see a slide presented by Brad Green, who was the lead of the Angular team about a year ago. And he presented this slide at NgConf last year in Salt Lake City. And what you see here is the size of an Hello World application. Using the Vue engine, the predecessor of Ivy, a Hello World application took about 151 Ks. If you use differential loading, which means that you're creating optimized bundles for modern browsers, for ECMAScript 2015 browsers, like Chrome, like Firefox, you ended up with 131 Ks. Using Ivy, you can shrink this a bit. Using Ivy, you are at 126 Ks for older browsers and 109 Ks for modern browsers. So this is not that much. This is nothing I would call home about, but if we look at the right bar, at the yellow bar, we see the potential of Ivy. When using the so-called Friddle Seekers API, we land with 14Ks. Friddle Seekers API because this API is currently a private one. That means it is not backwards compatible and not ready for production. But nevertheless, it shows the potential and it shows what we might get in some iterations. Perhaps you're wondering why Ivy can create such nice bundles, such small bundles, and to answer this question I have prepared a little demonstration. In this little demonstration I have prepared a Hello World application. This one here, which is just an app component and it has a property title that points to Hello World. Also, just for the sake of demonstration, it gets hold of an HTTP client using dependency injection. On the other side, the template is just data binding this title between two H1 tags, between an opening tag and a closing tag. Now let's see what Ivy is doing with the source code. Let's have a look into an ECMAScript 2015 bundle. And here we see first of all that Ivy is just down-leveling our class to ECMAScript 2015. This looks like what we have seen before. We don't have data types anymore, but the rest looks like the same. And then of course Ivy needs to put the metadata somewhere. The metadata and the template, and for this Ivy creates some static properties. Like this here, FAC stands for factory. This is just a factory function creating a new instance of our class. And normally this factory function is just newing up a new instance of app component. For very special cases we can get hold of a subclass of app component. This is mainly created here for subclassing components, and in this case the subclass is passed here and then the subclass is newed up. Also, Ivy already takes care somehow about dependency injection. This is what Ivy does with dependency injection. It calls a function directive inject and mentions the token. The more interesting part of the things Ivy is creating is this one here, the components data. The metadata for your component. You can also call it the component definition. As you see here, the component definition holds some metadata like the component type, like the component selector in a pre-parsed way. There are some variables used for housekeeping, used to initialize arrays with the right size. And then here we have the compiled version of our template, of our HTML template, just displaying the title within the H1 tags. As you see here, this template gets an RF parameter. RF stands for rendering flag. And basically the rendering flag has two values. If the first bit is set, then we are in the creation phase. Creation phase means that we are creating the template, that we are creating the component, which means we have to create all the HTML tags. Here, for instance, an H1 tag is created, and this H1 tag gets the ID 0. We have here a placeholder which gets the ID 1, and this is the placeholder where we will put our current value afterwards, for instance, our hello world string. And of course, because we are nice people, we are closing our H1 tag. This is the creation phase. This happens when the application is created. Then we have the second bit. If the second bit is set, we are within the update phase. And within the update phase, we are doing data binding. We are advancing to the element with ID 1. We are starting at ID 0, and here we are advancing to ID 1 just by increasing the value by 1. And then we are interpolating the contents of the element with the ID 1. It gets the title of our component. The title here, as you see, is a property of our component, and I think this also explains what CDX is doing. CDX, the context, is basically the instance of our component. Okay, so at the end of the day, Ivy is creating code we have created about 20 years ago by hand. It is as simple as that. We just have some functions that are called. And the most important thing here is we are using functions. We aren't using methods. Functions have one big advantage. Functions are better tree-shakeable. It is quite easy to find out which function is used and which function isn't. It is not that easy with methods because we have polymorphism, because we have dynamic binding, and so it is quite hard to find out with an analysis which method is called. But with functions this is quite easy, and so the whole Angular core is tree-shakeable. That means if we don't need to interpolate texts, this function here is thrown out. If we don't need lifecycle hooks, the logic for lifecycle hooks is omitted. That means Angular is very tree-shakeable on a very fine-grained basis. On the other side, the whole result here is quite close to traditional JavaScript, and this is also beneficial for smaller bundles. Okay, so at the end of the day, this source code is executed at runtime. It is more tree-shakeable. It is closer to JavaScript, and that's why we can produce smarter, tinier bundles. Perhaps you're wondering what you need to get Ivy, and the answer is quite simple. You just need Angular 9. Just migrate to Angular 9, and everything should work as before with Ivy. Okay, there might be some edge cases you are running into, and in those edge cases you might want to disable Ivy. You can do this within dsconfig.json, as you see here. There is a branch called Angular compiler options with enable Ivy. Just set it to false and then you have the good old view engine. In most cases it really should work. The Angular team did a lot of effort to make it backwards compatible. And this is for a reason. First of all, we don't want to have breaking changes outside of Google. But on the other side, within Google, we have about 2000 Angular applications, and of course, they shall not break even. So what is the roadmap? With Angular 9, we got Ivy, and the focus here was backwards compatibility. With Angular 10 and above, we will hopefully get new features based upon Ivy. There is a lot of potential Ivy brings, and hopefully the Angular team will use this potential. Perhaps you're wondering, well, are there only smaller bundles with regards to Ivy? And the answer is no. In short term, there is another feature we get because of Ivy, namely lazy loading components. Lazy loading components was not possible before. Before we had always to load whole modules, because all the metadata has been put into the modules by the compiler, by the old compiler. But now Ivy is putting all the metadata in the components itself. And so we have everything there we need to execute the component after loading it. That's why lazy loading is now a piece of cake. We can use traditional ECMAScript 2017 features like a dynamic import. We can point to our file with the component, and after that we can just grab one of the exports of this file. Here I'm grabbing the dashboard tile component. This is one of my exports. And then for reasons of backwards compatibility, I need this CFR, the component factory resolver, which gives me a factory for my Ivy component. This is mainly because of backwards compatibility to not break existing APIs. After I've got this factory using the CFR, the component factory resolver, I can just instantiate a component using the factory. For this I need a view container, which is basically a placeholder on my page. And within this view container I can use the factory to create my component in question. Also, I have to pass the injector to make dependency injection possible. You could even try to pass here a fake injector, an injector you create by yourself, and then the component would use this one. Okay, let me show you an example for this. Here I brought a tiny application that shows everything I tell you here in context. And this is about a dashboard where we can load dashboard tiles lazily. And as mentioned, those tiles are really lazy loaded. Perhaps you're saying, yeah, everything can say that, everyone can say that. Yes, everyone can say that, but let me prove it to you. Let's reload the page. Let's jump into the developer tools. Let's go to the network tab and let's press add tile, and here we go. As you see here, just a component is lazy loaded, not a module, just a component. That was not possible before. What does it take to create something like this? Well, let's have a look into our source code. Let's have a look into my dashboard, page component HTML. What you see here is we have a placeholder. Here it is an ng container. It could also be another tag like a div or a span or something like this. Here it is an ng container and it is marked with VC, with a template variable with a handle called VC like view container. Now let's have a look into the component, into our dashboard component, dashboard page component, yes. What we see here is I'm getting hold of my injector using dependency injection, and the same holds true for my CFR, for my component factory resolver. I'm also referencing my view container by mentioning this template variable, this handle VC. I'm loading this placeholder as a view container ref into my code. And then within my click handler, I'm just importing my lazy component. I'm referencing the file using a dynamic import. Then I'm grabbing out of those exports the export I'm interested into, which is here the dashboard tile component. For reasons of backwards compatibility, I'm creating my factory, and then I'm instantiating with the factory a component instance within the view container. As you see here, I can even get hold of my component instance and work with it as I would work with each and every other class and of course object. I can set some data like the values A, B and C for the bars that are displayed, and I can call methods like ngOnChanges. Awesome, so as you see here, lazy loading is really a piece of cake thanks to Ivy. Perhaps you're wondering if this is all, and the answer is no. Ivy has a lot more potential, and hopefully this potential will influence upcoming versions of Angular. So let's talk about what Ivy will enable us to do tomorrow. And first of all, here I have a word of caution for you. In the next parts of this presentation, I will use private APIs. So don't use them at home, don't use them in production. But I think using private APIs really shows how Ivy works underneath the covers, and it shows what will hopefully be possible in the future. And for this I will start with bootstrapping. Normally we need to bootstrap whole Angular modules. Even though our application just consists of one or two components, which might be the case with web components, we need an Angular module to bootstrap. With Ivy, this is not needed anymore. With Ivy, we can just call this private render component function. We can pass in our component, and then Ivy will render this component in the current page. It's as easy as that. That might be beneficial for small applications, but also for web components. What I did here in this example is I created a web component by hand. I subclassed HTML element that works in all newer browsers like Chrome, Firefox and so on. And then normally I would create a constructor, and within the constructor I would create some HTML tags by using inner HTML. We all have done this, or by creating some tags using document create element. Instead of this, I'm delegating to Ivy here. I'm telling Ivy, hey Ivy, it's showtime, please render the flight component, and render the flight component to this. This is here my web component, which means the web component gets this Ivy component. At the end of the day, for the outside, for the browser, this looks like a traditional web component. Within the inside, we have an Ivy component, pure Angular. Perhaps you're wondering why we need this, because we have Angular Elements since version 6, and Angular Elements is doing this by default. Angular Elements wraps an Angular component as a web component. Well, the answer is Angular Elements is focused on backwards compatibility, and currently it does not use this Frill Seekers API. Remember this yellow bar with 14 keys for a Hello World application. This is currently not used by Angular Elements. And so if we need something like this already today, we can hand wrap it using the Frill Seekers API, like I have done before, or we could use this open source project called NgElements. Hopefully in the near future, the Angular team will use this Frill Seekers API with a new version of Angular Elements. I think this was one of the more easy aspects of Ivy. The next one is quite difficult. So for the next one, please take a deep breath. This is quite a heavy one. It's about dynamic components and higher order components. As within every Hitchcock movie, I will start quite nicely and then it is getting more and more harsh. But first of all, let's get started nicely with a function. No one prevents us to create a class within a function. It is not that usual, but within JavaScript, within TypeScript, this is possible. Everyone who calls this function gets a new class per function call. And then no one prevents us for adding the metadata the Ivy compiler would add directly within this method. This is what I'm doing here. I'm adding my component definition. The component definition with the selector and with the template function. And then we can return this component, and what we get is a dynamic component. From this time on, Ivy treats this component like a traditional Angular component. That means we can really easily create dynamic stuff. But now let's go one step further. Let's assume we are passing another component as a parameter, and let's assume we are calling this so-called inner component within our dynamic component. We are calling it within the template of the dynamic component. What we now have is a so-called higher order component. A higher order component is a component that acts upon other components, like a higher order function is a function that acts on other functions. And for this I have, as I think, a nice use case, and this use case is implemented with this very technique. So let's have a look into our example for this. Let's say we need statistics for 2022. No problem for my application. I can just pass this URL parameter and then the title will show us statistics for 2022. This is nothing new, this is nothing special, but let's have a look into this dashboard page component. Let's find out how this dashboard page component is reading this very URL parameter. Let's move up here. Here we see an input that gets the routing parameter. Normally this is not possible. It was discussed in the alpha and beta phase of Angular. It was discussed if Angular components should be router aware or router agnostic. They decided that a routed component shall know the router directly. That means something like this is not possible with traditional Angular. If we wanted to create something like this, we needed a wrapper component which is talking with the router, which is passing all the routing parameters to this real component. And of course, in the past, we could write something by hand. This is what I did. I have called it routed component. Routed component. And as you see here, the routed component is not a big deal. It takes the activated route. Then within ng on init, it subscribes for all parameters, and the newest parameters are put to a property params. And then, of course, within the template of my routed component, I'm calling the inner component. Here it is my dashboard page, and I'm passing the parameter year to the input year. And so my inner component can just work with inputs. That totally works also with older versions of Angular. But if we think that we have this issue several times, we would end up with writing those outer component, this routed component several times, and it would always look like the same. We would always have some logic fetching the URL parameters, and we would also always have some logic delegating to an inner component. Everything that changes from time to time is the name of this component and the name of the parameters. So if you ask me, this is really a good example for a dynamic higher order component where all this wrapper code is dynamically created. And this is what I did. If we look into my HOC file for higher order component, we see a function here. And this function takes the inner component, which is in our case the dashboard page component. Then I'm dealing around with this inner component, I'm casting it to another component type, I'm taking out the CMP property, the component definition, and the component definition has a selector. And here, naively, I'm assuming that this selector is just an element. I'm grabbing out the element of the right location of this data structure. 0, 0 is here the right location if the element is just a name or just has an element name. Then I'm creating a class dynamically, and as you see here, this class looks like the class I've presented you before. It looks like my routed component, getting hold of the activated route, getting hold of our parameters, putting the parameters into a property, Then I'm doing what Ivy is normally doing. I'm setting up properties like my factory property, which is just creating a new instance of my higher order component, which is taking care about dependency injection. Also, I'm adding my component metadata. For this, I'm defining some properties like the directives. Here I'm telling my higher order component that it might reference my inner component, that it might call the inner component within its template. Setting a change detection strategy, I don't need any selectors, and then here I'm setting up my template function. In the creation phase, I'm just creating the inner component, an element for the inner component, where element name is the tag name I've inferred before, something like dashboard page. And I'm also passing additional stuff. Within the update phase, I'm just iterating all my routing parameters, and then I'm assigning all the routing parameters to parameters of these components, to inputs of those components using the property function here. As you see here, I'm passing some for this in question, and then I'm assuming that the properties have the same names as my routing parameters. At the end of the day, I'm returning this higher order component. Well, I agree, this is quite a complicated piece of Angular, but at the end of the day, you can wrap all those complicated stuff away. Just hide it behind one function so that your colleagues don't see it all the time. I don't assume that each and every developer is creating something like this. But if you have some infrastructure people in your company, perhaps they are creating some added-on functionality for you. And I'm assuming that a lot of open source contributors will use those techniques to provide some new stuff for Angular. Let us look how we can call this within our app routes. I'm just referencing my dashboard page component, and when referencing it, I'm wrapping it with route. And that's all. I'm getting my higher order components, my routed component automatically. Okay, so we can really dig deep into Angular and provide new features by hooking into Ivy. Okay, so the next topic is a bit simpler. It's about optional NgModules. You could also call it standalone components, because a component that does not need a module is a standalone component. And if it comes to this, perhaps you're wondering how one component does know which other components it is allowed to call. Normally, the NgModule tells us this. Normally, if two components are registered alongside within an NgModule, they are allowed to call each other. Now, as we don't have NgModules anymore, or as they are optional, they will go away, they will become optional. The question is, how can one component know which other components to call? And the answer here is quite easy. You just need to grab the component metadata, and the component metadata has a directives property. And now you can register one component metadata within the directives array. It could also be a function of the other metadata. Here in this case, I'm allowing my foo component to call the bar component. That means we are directly defining the neighborhood of a component. The official term for this neighborhood is compilation context. At the end of the day, this is what the compiler is nowadays doing for us. At runtime, Ivy is not interested into NgModules anymore. The compiler is moving everything from the modules into this directives property. Of course, sometimes we need to use several components together. For instance, here a bar component and a fizz component. And you could put those components into an array. This array could be exported by an index.ts. And I think that shows that also using barrels nowadays, that also using public APIs nowadays, with or without libraries, can be beneficial. On the other side, you will import this array from your index.ts, from your barrel, from your public API, and then you can work with it. You get hold of other component metadata and just assign this array with components to the directives property here. And so you can define the neighborhood of one component just by providing one line of code, just by providing this array here. If you think about this, this is more or less what the export section of NgModules is doing. But here we don't need the whole NgModule anymore, we are just going with the export section. Of course, defining this in an imperative way is somehow crazy. And that's why the Angular team is searching for ways to make this more straightforward. One proposal for this comes from Minko Getchev, who is part of the Angular team since more than a year now. What he did is he just forked Angular and he created some new stuff within his fork. He created a depth array within the component decorator, a depth array which takes several other components, directives and pipes. Perhaps you remember the time before Angular RC4. Before Angular RC4, we did not have NgModules. Before RC4, it worked exactly like this. And perhaps it will come back. All the good things are coming back, you know, and so hopefully we can use something like this in the future. But let me emphasize that this is just a proposal. Perhaps this proposal will be implemented, perhaps they will implement it in a different way. But making NgModules optional is on the agenda for the Angular team. Okay, let me show you a demonstration for this. In this demonstration, I'm moving to my dashboard tile module. And as you see here before, my dashboard tile component used a bar component. The bar component is basically the bar that is displayed within my dashboard. If you look here, we have 3 bars, a blue one, a green one and a red one. This is our own component here, just displaying the data and displaying this awesome tip tour text. I'm very proud of it. Okay, so in former days I registered the bar component alongside my dashboard tile component. Now I don't do this because now I can do something like this here. Here I have some pseudocode that is getting hold of the component metadata of the dashboard tile. I'm doing the same with the bar component. I'm getting hold of its component metadata. And then I'm saying, hey, dashboard tile, here you have the bar component, just use it. And so the dashboard tile component is capable of calling the bar component. Of course, this is somehow ugly, but I've done something Minko did. Of course, I was not capable of forking Angular, that's why I created a new decorator. A decorator called component depths, which is getting hold of my directives array, which just contains my bar component. And so my dashboard tile can use the bar component even without modules. Saying this, you don't need to be afraid about breaking changes, because I've told it several times before, NgModules will not go away, they will become optional. Let's talk about a last thing Ivy will enable. This is about zoneless change detection. Perhaps you know it, currently Angular is heavily using Zone.js. It's one of the dependencies of Angular, and it does a very difficult and also important task. It is the key for automatic change detection. We change a property and magically Angular knows this and updates our view. This is done by monkey batching. Monkey batching means Zone.js is just batching all the browser objects. It is modifying a lot of event handlers so that it knows after an event had run. After an event run, Zone.js knows, and then Zone.js will trigger Angular. It will give Angular a kick so that Angular knows, okay, now it's time to update all the data bindings. This is because an event handler can change all the data out there, and so we need to check if the bound data has to be updated. And this works quite nicely, but there are also some downsides. One downside is it has more than 100 keys, which is not that a big deal for big enterprise applications, but if you think about tiny applications or even web components, it is. No one wants to ship a 10K web component alongside 100K Zone.js. That will not work, of course. On the other side, it works magically. Someone said once ago that it works until it stops to work. And when it stops to work, we have a big issue. Diagnosing issues with Zone.js is everything but funny. And then we have another issue most of us are not aware about. This issue arises when we use ECMAScript 2017. If we downlevel TypeScript to ECMAScript 2017, async and await is not downleveled. It is used in a native way. And as a matter of fact, we cannot monkey batch async and await. We cannot, and Zone.js can't. That means Zone.js does not work with native async and await anymore. Nowadays we don't recognize this, because nowadays we are down leveling to ECMAScript 2015. And when this happens, TypeScript makes promise-based code out of async and await. And promises are just an API. An API can be monkey batched, of course. But if you feel that you are a hero, and if you try to switch to native ECMAScript 2017, you will see that even the Angular CLI gives you a warning. The good message is that Ivy does not care about Zone.js at all. Ivy does not know that something like Zone.js exists. It just cares about calling mark30. Someone has to call mark30 after we've changed the property. Who calls mark30 is not important here. It could be the component itself, it could be some part of the framework, it could be some class library you've downloaded. This is exactly what I did within my example. If we look into my example, we can get rid of zone.js. By the way, this has been possible since Angular 5. Since Angular 5, we can say, hey, please use the noob zone, the no operation zone, or our own zone implementation if we have such. Here I'm using the no operation zone, which is doing basically nothing. Quite a chilly guy, if you ask me. It is doing nothing. And so we need to do change detection by hand. Let's try it out. Of course, not everything works in here in my example, especially because some libraries depend upon zone.js. That's why this title is eventually displayed, but not from the beginning. But when clicking at more, we are seeing my dashboard tile is prepared for this future, for this zoneless future. This really works because the dashboard tile component is calling mark30 by hand. Every time I'm changing something, I'm calling mark30. And this is awesome on the one side, and on the other side this is shocking, because we all are using Angular to not need to do something like this. We all use Angular to get automatic change detection. And so the big question is, how can we get back automatic change detection? And there are some ideas. One idea is we could use observables together with a push pipe. That means our component is just exposing observables, like my price observable here, and then I'm binding it by means of the push pipe to my template. The push pipe knows when something changes because it subscribes to my observable, and after something changed, it just gives Angular a kick. And so Angular knows, okay, I have to update this very template here. Perhaps you're wondering, what's the big deal with the push pipe? Because the async pipe is basically doing the same. Yes, async is doing the same, but currently async demands that zone.js is here. Async needs zone.js, the push pipe doesn't. Saying this, the push pipe was an early experiment. It is about 3 years old, and it is just a proof of concept that something like this also works without zone.js. And there are some works. Some people try to make the push pipe part of NGRX. There are also some rumors that one day the async pipe could do what the push pipe is doing nowadays. It could be capable of working even without zone. Saying this, there is also another proposal. It has been presented last year at Angular Connect by Mike Ryan. Mike Ryan is one of the main people within the NGRX team, and he proposed a new library called NGRX component. Currently it's a prototype, but what NGRX component is doing is this, for instance. It will do a lot of stuff at the end of the day, but the current proposal also comes with this. We can subclass our component from reactive component. This is something that is currently discussed because it is not assumed that it is nice to force someone into subclassing. They are looking for other ways, but his proposal from Angular Connect is using subclassing. And by subclassing, we get this connect method. This connect method connects some observables, like this one, to properties like that one. That means my observable here is connected to my movies property. And what connect is doing now is it subscribes to this observable, and every time the observable emits a new value, the new value is put into a variable with the name movies. And besides this, connect is just giving Angular a kick so that Angular knows, okay, now it's showtime, now it's time to update our template. Within the template, everything is straightforward. You can use your state variable and then you can navigate to movies and all the sub-properties of movies. Those are just two proposals that are around currently. There are some more proposals like doing something what React is doing nowadays, providing a set properties function that is doing both setting your properties and telling the framework that we need now change detection to run. If you are interested into such experiments, look out my blog. I've written several blog articles about the potential of Ivy. So let's come to a conclusion. What did we see today? We saw that in short term, Ivy will provide us with smaller bundles. In long term, there is much more potential, like lazy loading components, like higher order components, like optional modules. If you don't like modules, you can get rid of them. You can use standalone components, and there will be zoneless change detection. And I want to finish this talk with a side of my most famous and most favorite scientist, namely Emmett Brown, PhD. Once he said, your future hasn't been written yet. And what he meant was, we don't know how those features will show up in the public API of Angular. But we know somehow it will show up because Ivy has been created with all those ideas in mind. I'm pretty sure that was exactly what Dr. Brown meant back then. Okay, so here you have my contact data. You find all my material, all my slides and examples on my blog. And you also find my Twitter handle here. Perhaps you want to follow me on Twitter so that we can stay in contact. Thanks for having me and have a nice day.
Thank you, Manfred. Thank you for your great insights. Do we have any questions here on location or online? Take your chance. Okay, so Manfred,
Okay.
thank you for your talk.
Thank you.
Thank you for great insights. Yeah, great. Now let me introduce our second speaker to you. He has around 10 years of industry experience as a senior developer. He's an Angular enthusiast and he's very keen, has very keen interest in testing, component testing, end-to-end testing. In our AURENA tech team. Let's welcome. Hi everyone.
So just putting this down. So welcome to Angular testing. It is not about the pain, it should be about the confidence. So if you're not yet a believer in testing, you may have heard your colleagues arguing about the value of testing. They've tried it, they maybe found it slow, complex, and maybe even distracting and unnecessary. And yet, there is this little nagging voice in your head that asks yourself, are you missing something? Should I push myself again and try to master this domain? Or are you more like us and you just started and tried to start writing unit tests and component tests? Then you are probably familiar with the behavior-driven testing tools like Jasmine and Jest, and then you probably know the 3 words: describe, it, expect. And if you take these and make a 3-letter acronym out of it, you know what you get? You get die. This is how many people feel when it comes to testing. It feels something like a little death. Hi, and I have to confess, I have written lots of bad tests throughout my career, but therefore I claim to have a little experience with it, and I would like to share that. This talk is entitled to building up confidence in testing. So the first thing we have to do is to reset our mind, how we think about testing. So if by the end of this talk you have a renewed interest and will in testing, so that you maybe try it out again and you have some new ideas and some examples by hand, then I think you will become a confident tester and therefore a confident coder in next to no time. Let's start with the why. Why do we even test? So you may also have this thought once that you sit in front of your code and you really don't know how you should now write a unit test or a test for this piece of code. And then you come to the conclusion and you think, maybe this can't be tested at all. And then you conclude that maybe there is nothing to test here, and that's what you say to your colleagues. But this is wrong, obviously. And to be honest, we all know it. Every responsible and professional developer knows that testing is just part of the job, right? We don't close a given task without having written a test for it, right? No. We don't do this. So the point here is we want to be good developers. We want to be professionals. And therefore, you know what comes next. Good developers write tests. So let me quickly tell you a story how this usually works out, at least in my experience. So let's assume we have implemented a new feature for our application. The end of the sprint is near. We are pretty confident it should all work quite well. We have tested it once, maybe twice. We've tested it manually, of course. And suddenly this little nagging voice pops up again in your head and tells you, Christian, you didn't write a test for this. You have to write a test for this feature. Otherwise, your colleagues will be angry with you. They will say that you're a bad developer and I want to be a good developer. So what comes next, of course, I write the test, but unfortunately, I write the test in the quickest possible way. And I'm sorry that I have to say this, but shame. This is a trap. We shouldn't do this. We should write tests for a different reason and for different reasons. And one of the main reasons I come up with are confidence. As said, we don't write tests just for the sake of writing them. We write tests because we want to be confident that our application is working correctly, not only now, but also in the future, when we probably make some more changes in our application. So we want to avoid bugs and we want to avoid regressions, but we also want to be able to refactor our code so that we are later confident to change internals of it. That wouldn't be possible if we would not have tests. Design. It's usually said that when we have a bad software design, that it's hard to write tests, right? So we could also say good software design means we can write easier and we can write easy tests. So we could conclude that when we write tests from the beginning on, that we create a better design automatically. And I would say, yes, that is true. We should do this. Speed. We don't only want confidence, we also want speed. Speed to be able to change quickly. Therefore, we of course need some kind of automated way, CI/CD pipeline, to be able to do this. But the only alternative that is viable would be basically to testing, and to automated testing would be manual testing, and this is obviously very time consuming and takes a lot of effort and therefore a lot of cost. And there's also another problem with manual testing, and it sits in front of the computer. It is us, it is the human error. There's a reason why tests should be executed by a machine, because a machine is not soft, a machine is not forgiving, a machine does not have a hard day or has to hit a deadline. So we should execute them automatically by a machine and not by us. Because we are soft, we are weak, we introduce the human error. We shouldn't do this. So, do you feel more motivated now? I don't know. I don't quite feel it. I think testing is still hard. You probably argue. So the thing is, we still don't know how to write tests in a good way. So I would even say a good developer not only writes tests, a good developer writes good tests. And we will have to take a look how good tests look like. The following are just some ideas I've created. You don't have to use all of them, of course. This is an illustration from the known book, Growing Object-Oriented Design Guided by Tests. It illustrates the chaos factor when you try to start testing at an early phase of the project, and therefore the chaos and uncertainty factor decreases. And when you start late in the project phase, obviously you increase the chaos and the uncertainty factor. Yeah, I think in the book the context of this illustration is a whole project, but I think we can take this principle and apply it to, for example, to our sprint or even to our daily work when we are starting a task. Next, I think we should all think about behavior-driven development. At least we should think about describing our tests in a behavior-driven manner, because therefore we automatically describe the behavior of our business and of our software and not some implementation details. If you don't know this, but this is actually executable code, you can run this code with the framework Cucumber. This obviously takes a lot of effort to implement, because you basically have to come up with your own domain-specific language. But as an alternative, we could also use some parts of this in our existing unit tests, for example, just in the description, or you could, for example, I do that relatively often and I really like it, to basically structure my tests into the parts given, when, then, and then. You should see nicely the given part are all my preconditions I have for this test. The when part is actually the action, the method I want to execute. Here it's a bit confusing because I call fixture detect changes, but that means in the Angular context, that means I want to render the thing, and I want to render it with my given variables and my given inputs. So render would be probably a better name to write there. But I hope at least to make a point here. So the next thing is also a little controversial. This is a paper written by Eric Elliott, and I really encourage you to read it, because it gives you a very different and total different view on mocking. It's more orientated to functional code, but he even mentions Angular and its dependency injection mechanism, and how you could see mocking as a code smell. So this could happen when mocking. First, I should have to explain what a code smell is. A code smell does not mean that there is anything wrong, definitely wrong at the moment. It could be just a sign or a hint that we are running into a problem. So, for example, when we write a test and we have to mock very many services or components have to mock, and we have to mock them, this could be a sign that in a way our business code does too much, is too tightly coupled and has too much dependencies. So we should listen to our test code and read its signs and interpret them. Another good point that he makes is mocking third-party libraries. We should also think about this, especially if we do this in our components where our business logic or our services where our business logic lives. We should think about it. I don't say that it's bad per se, but when we are mocking third-party libraries, we are making us dependent on this library, and we don't have this library under control, and when it changes, all of a sudden many tests will probably fail, and this is a really annoying way, because I think this is the so-called false negative test. It fails because we changed something, we restructured something, but it shouldn't fail because we didn't change anything on the behavior side. We should use. This is a rather boring topic, I know. Every sane developer now pulls out the testing pyramid out of his pocket, and I'm so sorry that I have to do this as well, because you probably all know this already, at least this picture, but I had to do this because it really gives us a lot of information and it tells us a lot. So the obvious information is, of course, that we need more unit tests than integration tests, and that we should have more integration tests than end-to-end tests. But the not obvious part is probably what it tells us about the amount we should have, how many tests we should have, how long should a test take to run. We should also think about how robust a test is, how fragile, is it flaky. So a test also gives us confidence at a certain level, and it means that we have to put in effort to write the test. And also a test can be accurate or not accurate in the sense that when a test is failing, when we immediately know why the test is failing, then it is an accurate test. So probably I give an example. The end-to-end testing part, usually end-to-end tests take quite long, so we shouldn't have too many of them. End-to-end tests tend not to be robust, because obviously we're testing our system end-to-end with many layers in between, and the probability that something can go wrong is just higher. So they are just not that robust as we might want it. But interesting point for me personally, when it's working, then it gives us a very high confidence that our application is working as well. Of course, writing and maintaining end-to-end tests means a lot of effort, and an end-to-end test is not accurate because you always have to take a look when it fails, what was really the cause why it failed. And this is annoying because this is time consuming. And the next thing that is why this is annoying is because the duration of such end-to-end tests, they take quite long to execute. So you have to find the error or the mistake, and maybe it's a false negative, and then you have to run it again, and this takes time. And therefore, in comparison, the unit tests don't take time. They are really fast, so we can have lots of them, and they are very robust because they test an isolated part of our application. They give us not that much confidence though, because we are just testing that one part probably. The effort is not that high, and it's really accurate. So when a unit test is failing, it should already tell you by its description, and you should already have a feeling by its description what went wrong. So let me introduce you to the ice cream cone. I don't know if you know this. It's basically a trap, I would call it. So it's the testing pyramid upside down. So you have more end-to-end tests and GUI tests than integration tests, and more integration tests than unit tests. And this is really bad, obviously, but we tend to fall into this trap because we developers like end-to-end testing because it's easier, especially if we have tests that is hard to unit test. We tend to like writing more abstract, more user-centric tests. This is one reason. And in the long-term view, there is always this, in the end, someone else will write these end-to-end tests. So as a developer, we may tend to like end-to-end tests more. And the management obviously also likes end-to-end tests because an end-to-end test is testing a real user scenario. And the more scenarios we are testing, the better it is. But unfortunately, it would only be the case if we have endless time and endless money. So this is a trap we should watch out for, and so that we don't fall into. So this leads me to the current situation here at AURENA. I would say that we currently have a big manual testing umbrella in place. So this doesn't mean that we don't test our software. Don't mistake that we don't test our software. We test our software extensively, and I should have made this bigger because it's really a high effort and it's really annoying to do it over and over again, and you always try to postpone it and do it at the latest possible point in time, which is bad also, because when then something is wrong, you have to do it again and again. So we are now currently in this situation where we try to come up with a nice or good test coverage, and we are thinking, or we have already started to begin to set up the infrastructure to get a better test coverage and get some more automated tests, especially in the front end. So for us, the classic testing pyramid doesn't fit very well because we have lots of code already, and they were written not with unit testing in mind. So they are really hard to unit test probably. So this does not really make sense for us. And luckily there is this guy named Can't See Dots that came up with the so-called testing trophy. It's another form of a testing pyramid, and I think it's there since a couple of years. And the basic statement of it is that it has more integration tests than unit tests. And this kind of sounds like a contradiction to the things I said before, because I said, yeah, we don't like to fall for the ice cream cone trap, and we would like to have this nice pyramid shape. But the thing is, this makes sense for the front end, and when we define the term integration test a little bit better, because I think every other person has a different view what an integration test really is. I read about the terms integration test and integrated test, and I want to use them now and explain them. For me, integration test is a test that only tests one integration of two parts. And an integrated test would be a test that is testing many or more integration points between many parts of a software. So, for example, an Angular component test that is booting up the template and where we are testing the template can be seen as an integration test. And I would call this the perfect example for an integration test, because it's testing exactly the integration between the view and our component class. This can be done, and this is why this testing trophy works, because we mock out all backend calls, and therefore we should be fast enough because it boots up fast enough. So yeah, we will see how this works out. Obviously, we just have started with it. So if you have experience with it, I would be more than glad to hear about it. So let's do a quick demo. I would like to show you a basic Angular component test and walk you through some thinking process I have when I write them. So this is our web platform website. There you can bid on different items. We call them lots. A lot is a Posten in German. So we can bid on multiple lots. And for example, if we would like to bid on the Audi, I zoom in, we can there see the aktuelles Gebot, the current bid. We see the bieten button, and if we press it, there comes up this, animates up this overlay where we have to confirm our bid so that you don't accidentally place bids on random items. So it has to be a two-step process. Then you confirm the bid, and then you should basically see a little green border and the thumb up, and the current bid should be updated with your bid value. So I would like to now test this behavior of confirming a bit. This card that we see here is implemented in one container component, and it's called lot container component. And I have a really simplified version of it because we should start a guessing game afterwards, how many lines of codes this component actually has, because it's pretty much optimized in a performance view. So for us, though, only relevant are the current bit field that holds the current bit value and the confirm method that actually just calls a service that I didn't even inject it, because just imagine we have a constructor here and we inject the bidding engine, and then we are placing a bid and we get in return the updated and increased bid. So this should show the method. So when it comes to testing, generally, or when we are using the Angular CLI, the tests are generated automatically for us. So they have a default name. With this with this slide, I just want to point out real quick that, yeah, it is a standard name. Don't be afraid to change it if needed, and don't be afraid to generate multiple files and multiple spec files if they grow big. So for the beginning, we have a pretty much regular test setup for testing an Angular component. We have a name for our test group. Don't really like it. We probably should come to that in a later point of time. We always have to configure the testing module and provide it with the dependencies and with the component itself that we want to test. What's interesting here is, and what I want to show with the provider's bidding engine stub, is that we don't want to test the services that we are using. We just want to test the component in isolation so that we can keep and get confident about the working of the component. So we are passing a stub there. Then, of course, the usual process of creating the component, we get a component fixture back. That's just the wrapper that Angular provides us to communicate with the isolated component that is under test. And then we can pretty much start to write our first test case. I gave it the first description that came into my mind. I don't think that it's perfect, and probably we will change it. I also want to point out the basic given when structure I like to put in there, just to get a drive and to get a start and to know where to start. I always try to start with the when part and place the system under test there and call the method that I want to test. And then I'll try to fill out the other parts and maybe even rename some things. So here, for example, we see that we are calling the confirm bid method, and we also have this confirm bid string in the text description of the test case. This already smells like we would test a method and not a behavior. So maybe we should change this and we should start testing the behavior, because when someone changes the name of the confirm bid method, I'm pretty sure nobody comes up and changes the name of the test description, and then this runs out of sync, and then there is a point in time somewhere where you don't know what the test should actually do. So it's always better to try to come up with a behavior that we describe and that we want to test. Confirming a bid increases the current bid is also not the best one, I think, but it's better than before. So now I put in the given part where I describe my preconditions. This would be the current bid value and the time of the fall of the hammer. This is basically when the lot is sold. And then what you probably can't see anymore, the when part, there it should be better. Then we call confirm bit, and then we expect that the current bit got increased by 500 for whatever reason. We don't know yet. Okay. So do you think this is fine and that we have written a good test? Because I'm sorry, because we are not, because I have several issues with this test. So the first one is that I really don't like this describe lot container at the top. It doesn't describe behavior as well, but maybe we would like this output to see it in the console, that when something goes wrong, we see what component was, or what component was it that had a failure. So maybe we should think about nesting describe calls, and yeah, maybe we do that in a minute. I also don't like the description of the test case itself. It's still not good, I think. And a real big problem is that we are still not testing like the user would use this component. We are booting up the component with its template, but we are calling the confirm bit method on the component instance, and we asserting the bit value, the new bit value with the variable on the component instance. And this would a user would obviously never do this because he can't. So a user would always click the button Gebot bestätigen, and the user will always check the DOM and the view whether the outcome is right. So to be more confident that our component is working, we should test as we would be a user. So let's quickly go through the steps. First, I gave a really expressive sample how we could write the test description. I personally really like that. We could write given, when, then, again, the behavior-driven style. And here we basically describe in words exactly what should happen later in the test execution. So this one should match, and therefore we always can verify if we're doing the right thing and if we're testing the right thing. So I really like this because it's really clear. It says give them a lot container with a default size big. We didn't know this before. This was just some context information that the developer had, but we should put this into the test description because it's the default size we're using here. And with a default step of 500, the default bit step, with a current bit of 12,500 and with the fall of the hammer at the timestamp, when I place a bit with a minimal bit step and confirm the bit, then I should see that the current bit is 13,000. That is a description I really like. So you may have noticed that I also inserted a second describe block where I try to more explain the behavior we are testing, so bidding on a lot. And then we still have the problem with the implementation details, and now it gets messy because this is just an option, yeah. We could, of course, take the native element from the debug element that Angular component fixture provides us and use regular DOM query selectors to get to the button and click it. The same with the then part. We can get this button with a data test ID and then make sure that it works correctly. But this is a real mess, and it's a really simple test case, and it's already not readable at all. So we still need a solution for that, I think. And therefore, I would come up with these two great implementations of testing library, and its name is actually testing library. It comes from Kanzi Dots, and the wrapper for Angular is from Tim de Schreier. He's a real active guy in the Angular open source community, and he's really putting out some great work there. So when we use this library, we can basically reduce this to a render call where we pass the component we want to render. We pass the inputs we have. We then get back so-called queries that enable us to select the DOM, but we don't see it. They encapsulate that us away from us. And then we can actually, like the user even, not with the data test ID anymore, we can select by the text of the component view. So we can select a button by its text, and this is the real user behavior. He does it exactly the same way. He searches for the text and he clicks on it. So I think this is awesome. In the same way, we can use the get by test ID method to fetch the content of the updated bit value. Great. So the key takeaways from today would be summarized in probably why we test, how we should test, and what we test. And of course, we test because we want to be confident, we want to have good design, and we want to be fast with our changes. How we test, we should start early to test. We should maybe think about behavior-driven development. At least I claim we should avoid mocking probably, or mocking too much. We should care deeply about the cleanliness and clean test code. We should avoid testing implementation details. And the what, obviously, yeah, take the information that the testing parameter gives us and apply it to your use case. For us, the testing trophy was the best way currently, I think, but there are probably many other ways that are valid and make sense. So I don't say don't unit test anymore. This would be the wrong message of this talk. Just for us, it makes sense to start from the top and to start with integration tests to get a better confidence about that our components are working. So thanks for your interest.
Thank you, Christian. Thank you for your great talk. Do we have any questions about testing? Here we go.
Isn't it somehow critical to rely on UI details in the test, like that the button is named Gebot bestätigen, or that the currency value is formatted in a specific way? Because if I change it, this thing, it might be the 100 test fail out of the blue.
Yeah, of course, but it is the real behavior, and if you want to test the real user behavior, what would you do? I don't know. What would be your advice to do this? Because I want to test the real user behavior, and when it changes, the test should fail. It fails for the right reason, in my opinion. And if you have 100 tests for it, maybe that's too much. I don't know. Okay. We can discuss this later. I'm interested in that.
Do we have any further questions?
Okay,
sure. There we go.
Maybe to the testing pyramid and the trophy.
Yeah.
I think the trophy really makes sense, because I think if the time is very limited, there is the opposite danger to the cone, that you start writing unit tests and then you just don't have time anymore for integration.
Yeah, that's right.
End tests, and that's also not very optimal. So,
yeah,
in my experience,
sure.
you have to be careful that you think very well where do you want to invest the time that you have.
Yeah, agreed.
How can you invest it in the best way,
Yeah.
with the best value? And it might be that it's you have to think what gives you more value.
Yeah.
Writing a little more integration tests or focusing on
Yeah.
unit tests.
Totally agree. Yeah.
Thank you. Any further questions? In that case, thank you very much.
Thanks.
Before we close the meetup for today, I would like to have Manfred again here on the stage just for a short chat. Yeah. I mean, we were telling our audience that you're a great speaker and that you're a trainer and a consultant, and I really would like to talk with you.
I do my best, yeah.
Could you come over?
Yeah, of course.
Great. I would like to talk a little bit about your work at Angular Architects. Could you give us just a general overview? What are the use cases? What are you working on?
Yeah, so we are currently about 10 people and we are helping other companies with Angular. We are doing a lot of trainings there. That could be an Angular introduction, but Most of the time we are doing more advanced trainings. We are calling one of our trainings Angular for Enterprises, and it's a lot about architecture, how to structure the application so that it keeps maintainable, how to use NGRX and Redux state management, how to use authentication techniques and so on.
Okay, so what would be a use case for a company to contact you?
So very often they are saying, hey, we are starting with Angular now and we want to make sure that we are do it right because we are creating a product that needs to be maintained for the next 10 or 15 years. Or sometimes they are saying, we already have something, we started with Angular 2 years ago and now we need to scale our team or to scale our customers, and so we need to add new features. And at this point, they want to make sure that they do everything right, more or less, so that they can achieve those goals.
Okay, okay. So let's make a harder one. You started with Angular, you pursue Angular. Why did you never think about React or Vue, or did you, and if so?
Well, I liked into React, and I looked into React, and I also like it. But I had to decide for one technique, because in my position, you need to be very deep into one technology, because my job is to help people that are working on a regular basis with one technology to get rid of the issues. And so I decided for Angular. At the end of the day, I think all of those frameworks are doing a great job and they have nice concepts, and sometimes one framework is borrowing some features from the other one and vice versa. What I like at Angular is it provides a lot of stuff out of the box. It starts with the CLI, we have components, we have dependency injection, we have testing, end-to-end testing, unit testing, we have BWA support, and so on and so forth. So a lot of things are there, and it is somehow guaranteed that those things work together today and in the future.
So if we look into the future of Angular, let's say the next 2 or 3 years, what do you see as the next big changes, technical-wise, but also in terms of the usage, in terms of the use case?
Yeah, so I think Ivy itself is a big game changer. We don't see much of it nowadays because all the potential is currently behind the covers. But it has been created with a lot of ideas in mind. I've mentioned today, for instance, standalone components, which is necessary for a proper web component story, for instance. On the other side, there are a lot of other stuff coming up. For instance, the Angular team is experimenting with partial hydration, which means you get an index HTML and the rest of the page is lazy loaded on demand. Currently, pages are loaded lazily, but then parts of the pages are loaded lazily, because if you think about a shopping system, we don't need each and every component at the same time.
Okay.
So that will be a big deal for public-facing applications and in general for performance.
Okay. So Manfred, again, thank you very much for your insight. Just stay with me a little bit more.
Thanks for having me.
Yeah, guys, we come to the end of this meetup today, but there will be another one very soon, I guess. So I want to thank all of the speakers again. Thank you, Manfred. Thank you, Christian. Thank you thank you also to my team. A big thanks also to the team for organizing the event today. So I hope you really enjoyed the evening with us. Thank you for being here with us today, and have a good night and stay curious. Thank you.